Okay, so now let's discuss about headers. So first of all, we are going to talk about TCP header, TCP header and UDP header. Okay, so let me show you header first of all. See, this is TCP header. Total how many row are there? One, two, three, four, five, and after that optional field is there. This is not in used for us. So you can see here there is one separate field for source port, and total length of one row is 32 bits, means source port is taking half portion, means it is an 16 bits value. So there will be information of source port number, destination port number. Okay, as you already know that whenever transport layer will receive any data from upper layer, from the session layer or from the application layer, first of all it will add a header, transport layer header, or transport layer header can be TCP header or it can be UDP header. If transport layer is adding TCP header, then transport layer will add these all information: source port number, destination port number, sequence number, acknowledgement number. There will be information about header length. There is one field called reserve field, flag field, window size, and checksum, and after that urgent point. These all fields are there inside TCP header. Means one TCP header contains these all information, and send message is nothing but a TCP header. So send message also carry these all information. Okay. So here is the some few introduction about each field, like source port number. Source port is an 16 bits value that specify the port number of sender. Destination port is again 16 bits value that specify the port number of receiver. And sequence number, a number used by TCP that puts the data back in the correct order or retransmit missing data during process called sequencing. So that's why we have sequence number filled inside TCP header. And what is the length of sequence number? Length is 32 bits. It is an 32 bits value represented in decimal. So range can be 0 to 2 to the power
16.
32. 2 to the power 32 values are there. Like your IPv6 address, around 4 million. Around 4 million billion. Okay. After that there is acknowledgement field. So acknowledgement field, the value is TCP octet, that is expected next packet. The value is TCP octet that is expected next. Let's say if I am receiving, I am a client machine or sender, and I am receiving acknowledgement on 101. That means destination machine is requesting for 101 sequence number. A packet on 101 sequence number means next packet. That means we have already delivered, or receiver machine have already received all packets successfully till 100 sequence number. Getting my point, guys? Like this, if here I have one sender machine, if here I have one sender machine and I have one receiver machine server, I have sent 100 byte data, right? So the server will send acknowledgement on what acknowledgement number? 101. That means I will came to know that till 100 byte data server have received. Now let me send next data on what sequence number? 101. and again length of data is 100 byte. So I will receive acknowledgement on what acknowledgement number?
201.
201. Very
zero
good.
two two zero.
201, not 2. 201. That means I have received data of 200 byte. Means this 100 byte and this 100 byte. Right? Send me the next data. And client machine will came to know that, okay, I am receiving acknowledgement on 201. That means till 200 byte it server have received. Is it clear? Is it clear to everyone? Yes or no?
Yeah.
Yes to all. Somnath, Prem, tell me.
Yes, sir. Yes, clear.
Okay. After that, there is one field called header length. Header length. So it is the size of TCP header. It is the size of TCP header. Let's say size of TCP header is 20 byte. So header, inside the header length field, there will be information about 20 byte. So it is TCP header size, which indicate where is the data begin. Let's say a receiver machine have received one data, right? And at transport layer they have checked that header length size is, let's say total size of data is 100 bytes, and transport layer header is 20 bytes. Means TCP header is of 20 bytes. So that means how many data are there? What is the amount of data? Actual data 80 bytes, right? So with the help of this field header length, a receiver device will came to know that from where data is starting, data begin, which indicate where the data begin. By default size is 20 byte. By default size is 20 byte. One very interesting thing is, see, let's say here I have sender machine and we have receiver machine. And guys, here is one PC. Here is one PC. This PC is connected with one switch, and this switch is connected with one router R1. This router is connected with R2. This router is connected with R3. And here we have one server. And this client machine want to send something on this server. On this server. So your data will go through all router. And you guys know MTU. What is MTU? Maximum transfer unit. The amount of data that router can transfer at a time. MTU. Let's say here I have one router and this is the interface of router F0/0, and MTU of this interface is, let's say, 1500 bytes. That means this router can forward only 1500 byte of data from this interface at a time. Router cannot forward data whose length is more than 1500 byte from this interface from fast Ethernet 0/0. If router will receive a data whose length is, let's say, 1600 byte, router will simply drop that data. Maximum transfer unit. It can receive, right, on this interface it can receive more than 1500 byte of data but cannot transfer. MTU is not like receiving, it is like transferring the amount of data that router can transfer from their interface. Okay.
So how that MTU will decide? That is
Yes,
Let's say we
yes,
have two
it can.
router and I have just purchased from Cisco R1 and R2. Both have one interface, right? Through this interface only you will connect these two devices together, these two router together. So this interface will have one physical MTU. Router cannot transfer data more than that MTU from this particular interface. And as I am telling you that by default MTU of all interfaces like logical or physical both on Cisco devices is 1500 byte. 1500
So that is
bytes.
1500 so by including 20 bytes of header, right?
Yeah, 20 bytes of header. So whenever a client will generate data, right, they will already subtract header length according to MTU. You know, while three-way handshake, there will be one more function. See here. When sender machine and receiver machine will form TCP connection, it will negotiate minimum MTU between source and destination as well. Let's say here MTU is 1500 byte, here MTU is 1000 byte, and here MTU of this interface is, let's say, 1000, 2000 byte, and this interface MTU is again 1500 byte, this interface 1500 byte, this interface have 1500 byte of MTU. Okay, now when it will send SYN message and SYN plus ACK and ACK message between source and destination, when they will exchange these three messages, that time this sender machine is going to negotiate minimum MTU as well. That what is the minimum MTU between source and destination? So minimum MTU is 1000 byte between source and destination. Yes or no?
Yes.
So
Yes, yes.
whenever this client machine will generate data, it will keep this thing in mind that I can generate maximum size of data is 800, sorry, 900,
80.
900, not 80. There is 20 bytes information at network layer also. So 860, sorry, 960 bytes. Actual size of data will be 960 byte. And when transport layer will add 20 bytes information, data will become 980 byte, 980 byte, and at network layer will also add 20 bytes header. So total length of data will become 1000 bytes. After that it will forward it to switch will forward to router. Otherwise, see, if the length of actual data is 1000 byte, so what will happen when transport layer will add 20 bytes information and network layer will add 20 bytes information? Now total length of data is 1040 bytes. Right, switch will forward it to router can forward, R1 can forward this traffic, right, because MTU is 1500 byte and the size of data is 1400 and 1040 bytes. But when router 2 need to forward it to router number 3, router 2 cannot forward this data because their MTU size is 1000 byte and data length is 1040 byte. So router 2 will drop the packet. See, router have brain. In that brain we can tell to router that whenever you will receive data whose length is more than 1000 byte, then you please divide the data into two part or divide the data, and after that forward that a small part of data to your neighbor, but by default it will discard it. Okay.
So suppose
Okay.
if the package is more than 1000 bytes,
Hmm.
it will fragment the data into smaller frames, then
Yeah,
it will pass to, okay, okay, okay,
then it can pass, right? That is
okay.
fragmentation. And now
And
see
also,
this client,
like,
yeah.
yeah, we can assume that MTU, we can assume as a unit in the router, they kind of a port.
Yeah, you can say, just I am going to give you practical right example of this also because you guys have
Okay.
lots of confusion regarding MTU. Okay, don't worry, I am going to show you one practical on it. See, if this client machine need to send one data to the server and length of data is 5000 byte, 5000 byte, 5000 bytes. So this client machine need to divide this large amount of data into a smaller part. Yes or no? So who will
Yes.
divide this large amount of data into a smaller part? Not application layer. Application layer can generate any size of data. It is responsibility of transport layer. Transport layer is going to divide. If you are using TCP, then it is going to divide this data into a smaller part. And according to MTU, because only transport layer have knowledge that minimum MTU between source and destination. In fact, only TCP protocol have this knowledge. So TCP protocol will divide this data. If we are using UDP, so UDP can send any size of data. Then it totally depends on router, that router is performing fragmentation or not. So second function of transport layer is, you can say, dividing large size of data into a smaller part of data, and this is nothing but segmentation. Segmentation means dividing large size of data into a smaller size of data by transport layer or by TCP protocol. And sometime you will see router is also dividing data, right? But router will divide data at layer 3, not at layer 4. That is called fragmentation. Fragmentation. Segmentation and fragmentation. I am going to show you, more about fragmentation and segmentation. I have a separate documentation on it. But dividing data at transport layer is called segmentation, and dividing data at network layer is called fragmentation. So
So
whenever transport, yeah,
in OSI model, we understood that data can be divided into frames in transport layer, right?
segment into segment, no
Into
Segment.
segment,
yeah,
in transport layer only.
exactly.
Now, if the router is also doing the same on the layer third, that is a data link layer.
No, network layer.
Network.
Okay, yeah, on a network layer. So there are two layers which are fragmenting data.
Yeah, exactly.
But I mean, from layer 3, that is from the sender side, right? I mean, from the receiver side.
Router will only, there is no concern of sender or receiver. Sender and receiver means end devices is never
Hmm.
going to perform fragmentation. Fragmentation
Right.
will perform by router only. This is concern of router, that router is not capable to transfer this size of data. So router
Okay.
will perform fragmentation, and segmentation will always perform by client machine who is
Okay.
sending the actual data. And transport layer is dividing large size of data into a smaller part of data according to MTU. Based on MTU, what is the size of minimum MTU? Okay, let me show you here in GNS3. Let's say in this diagram you can see here is one PC, and this PC have IP address 10.1.1.1 and router have IP address 10.1.1.10. Let me configure this scenario R1 and R2 only. Sorry, client 1 and router 1. So on client PC, first of all, I am going to configure one IP address, and I am going to configure one IP address on router. See, on router fast ethernet 0/0, interface fast ethernet 0/0, and say no shutdown. And then I am going to say IP address 10.1.1.10 255.255.255.0. I have configured the IP address on interface fast ethernet 0/0. Now on this router, if you will check detailed information of interface, so IP interface fast ethernet 0/0. So IP interface fast ethernet 0/0. Here also you can see MTU is 1500 bytes. That means this interface can transfer maximum size of data is 1500 byte, not more than 1500 byte. And from client machine 1, I am going to do one thing. On client machine 1, I am going to configure one IP address here, interface F0/0. Say no shut, and IP address is 10.1.1.1 255.255.255.0. Let me check the connectivity ping 10.1.1.10. See, I am able to ping the router from client machine. Yes, I am able to ping. But if I will change the size, here I am going to say size is more than 1500 byte. 1600 byte. Still ping is working. How ping is working and why ping is working? Hmm?
It
If I
divides the
will set
data.
any
That's all.
size, see ping is working, still ping is working. That means router 1 is able to forward the size of more the data whose size is more than 1500 byte. Ping, if anyone is thinking that this router is ping and size 1600 byte. If anyone is thinking that from router cannot ping client 1, so you can see, getting my point. And I am going to show you one more interesting thing over here. See, first of all, let me delete this section and this client machine also. Now it's fine. Here on this client machine, IP address is 10.1.1.1, and I am going to connect one more router here. R1 is connected to, let's say, R2. Yes, if anyone want to speak.
Yes, actually, the as per the IEEE standard, so basically it should accept 1500. How it is accepting more than
Fragmentation,
1500?
fragmentation. It is performing fragmentation. I am going to show you this only here. That why router is sending the reply message if the length of data is more than 1500 byte. Router is
Okay,
performing
and
fragmentation. Router is also dividing data into a smaller part.
So you mean to say that as router is working on network layer, right? So when it's receiving the data from the other end, it it from router side, it will defragment the data into smaller pieces, then it accept.
Wait,
Means,
1 second. Okay,
see, actually, you shown that 16,000 bytes. Okay, means it will divide like 10 packets, like 1,600.
exactly.
It will divide that 10 packets. That every packet is having that size 1,600, right?
Right.
Should be 1500, right?
Yeah, yeah. It should be 1,500. The default value.
Here IP address is 12.1. Here IP address is 12.1 and here IP address is 12.2. First of all, if I will ping 12.2 from this client PC, will ping work? Will ping work?
No.
no.
You
No,
should
no.
configure the default gateway.
Yes.
I have already configured the default gateway. From client machine, if I will ping 12.1.1.2, it will not ping. The reason is router 2 don't have any route available for 10 network.
Static route we need to configure.
So here, if you don't know this, don't worry. Here I am going to configure one route for 10.1.1.0, 255.255.255.0 and 12.1.1.1. Oh, next hop is invalid.
You should configure in R2, right? This is R1.
R1 IP
We
route.
need to upload it both of them.
Yeah. Now if you will check client is able to ping this IP address or not. So you can see client is able to now ping. Right? Ping is working. I'm going to do one thing. I'm going to capture the link between router 1 and router 2. First, I have captured the link. Okay. Now, I am going to set MTU of this interface is only 100 byte for better understanding. I am going to set MTU 100 bytes here. So on router number 1, go to interface F1/0 and say IP MTU, I think, or MTU directly, MTU 100 byte. We cannot set 100, we can set MTU value from this range. Minimum value is 1500, so okay, let's say 1500. Fine. MTU of this interface is 1500. And from the client machine, I am going to send one data whose length is, let's say, 5000 byte. Length is 5000 byte. So from client 1, say ping and 12.1.1.2 and repeat 5000. Sorry, not repeat, size 5000 byte. Ping is working and here is the capturing. See, are you able to see fragment packet, fragment 1, fragment 2, fragment 3? Then first request message, and if you will open any message, let's say I am opening going to open this fragment packet. Let me open this fragment packet. What is the size? Size of data is what?
1480.
1418. And after that there is network layer 20 bytes, and then layer 2 MTU. So layer 2 MTU, here we actually it will not count layer 2 MTU, because this is Ethernet header is header at layer 2, and we have separate MTU at layer 2, that is layer 2 MTU. So total size of data is 1500 byte. 1500 byte. So
So the
it have sent
1500 is without the Ethernet header.
without Ethernet header.
Okay.
We are not including Ethernet header. Why? Because Ethernet header is layer 2 header. That is part of layer 2 MTU. Layer 2 MTU is maybe different. Okay.
Okay.
And actually, you know, layer 2 means at all router, at every router, layer 2 header will be removed on receiving interface, and while transmitting it will add new layer 2 header. At each layer, header will swapped by router. Layer 2 header will swapped by router. So that's why we are not counting layer 2 header size. When router 1 will receive the packet, there will be layer 3 information, L3, there will be L2 information, right? When router will L2 information, when router will receive this frame on fast Ethernet 0/0, it will remove layer 2 header, and after that it will process the data, and then while transmitting from fast Ethernet 1/0, it will add layer 2 header, L2 header, L2 header, L2 header. So in MTU maximum transfer unit, L2 header size is not included. Done. So this router, okay, first of all tell me, this machine will divide data into how many parts? Total size of data is 5000 byte. 5000 bytes. Packet 1 size, let's say segment 1. Transport layer have divide the data into segment 1. What will be the size of segment 1?
960.
No, MTU is minimum MTU is 1500 byte, na? So 1480 byte. Right, in the same way segment 2 will have also same size, segment 3 will have also same size. So here again we have 1500 and 1480 byte. Actual data size is 60 byte. 60 byte here and 60 byte here, 60 byte plus transport layer header. Let's say this is a small part of data. So total is 1460 plus 1460. 1460 plus 1460 plus 1460 plus 1460 plus, okay, not plus 1460. Can I back? Okay. 1400 40,000 sorry 4380 byte will be in segment till segment 4, and in last segment there will be 4380 4380 4380 4380 and minus 5000. This will be the size of last segment.
One doubt I'm having. Actually, MTU
Yeah,
works on layer 3, right? So it should not include this transport layer header as well. So you are adding 60 bytes from, sorry, 20 bytes from there also.
sorry, can you again repeat?
MTU works on layer 3. Okay,
MTU,
so
yes,
yes,
MTU works
so
at layer 3.
you are adding transport layer header as well. So TCP header as well. So 20 bytes
20
you
bytes.
are yeah, 20 bytes you are decrementing from their total size. So I think
Right.
it should actually.
No, here we will add, this is actual size of data. How many segment will be there? 5 segment will be there, na? Segment 1, segment 2. Segment 2
No, my
size will be,
no, my question is like total it is 1500. So out of 1500 MTU, since MTU works on layer 3, so it should decrement the 20 bytes of header from IP header. So it should not include or exclude this. It should not add this TCP header or something.
Means it should be
Means that
1480.
in the fragment packet there will be no TCP header.
Correct.
So already.
Then it should be 1480, no, sir? Instead of
yes, yes.
1460.
1460 is the actual size of data. Here
No,
we
it,
will add transport layer header plus network layer header.
See,
So I
that's
just
what.
want
How
to know.
come network layer header is coming here? Because it is a transport layer. MTU is a transport layer, right?
No, no, it is.
Transport layer will divide this large size of data into a smaller part of data. After that it will add TCP header, then it will hand over to network layer, to lower layer. Yes, still doubt?
Yeah, still I'm having doubt.
means now you are explaining about that segmentation, right? Transport layer means.
Yeah, only segment, we are talking about segmentation, because here this, in this scenario router is not going to perform fragmentation, na?
Okay.
Router is not performing fragmentation here.
Means that MTU it will work in transport layer also, right? Transport
Right,
layer, network layer, and data link layer in three.
exactly.
Okay.
Okay, so when this client machine need to send 5000 byte of data, then it will send in 5 part, in 5 segment. It will create 5 number of segments. Segment 1, 2, 3, 4, 5. Last segment will have data of 620 bytes. And if I will tell to machine that please generate a data
सर
whose size should be
सेगमेंट तो चार ही
5000
होगा
byte.
ना,
हाँ,
सेगमेंट चार ही रहेगा.
ओके, 4 ही रहेगा, श्योर.
यस सर.
एक डिलीट कर देते हैं यहाँ से बीच से, फिर सही रहेगा ना?
ओके
शायद
ओके.
अब सही है.
जी सर।
साइज यही रहेगा, साइज ऑफ इच सेगमेंट इज सेम, इज करेक्ट. $1,460 plus 40, you can calculate it. Okay, okay. And now let's say if I am telling to this client machine that
Is also right.
please send the data whose size is 2000 byte, 2000 bytes. I'm telling please send data whose size is 2000 bytes. So this time transport layer is not going to divide large size of data into a smaller part of data. This time transport layer will add header over here, 20 byte header directly, plus 20 bytes, and network layer will also add 20 bytes header. So total size will become what? 2040 bytes. And this time this client machine will send 2040 bytes data at a time to router number 1. Router 1 can receive it, but while transferring it to router number 2, it will perform what? Fragmentation. See how it is going to perform fragmentation now. What router will do? First of all, let me clear it. Okay, and now from client 1 I am going to ping again and say data length is 2000 byte. Okay, okay, see, it have router have received the data. First router will receive the data. What it will do? It will fragment it into how many part? Into how many part router will divide it? Definitely into two part, because total size of data is 2040 byte, 2040 byte. So it will divide 2040 byte data into two part. First size of first packet will be what?
1020.
1600.
Huh?
1020.
20 or 80? This is network layer network layer header included, means actual size of data is 1416.
Mm.
It will divide this data into 1460 plus plus here also you can see the difference between segmentation and fragmentation. Segmentation is what? Dividing large size of data into a smaller part. Both is same, segmentation also and fragmentation also. But segmentation, it is done at layer 4. Fragmentation, it is done at layer 3. It is done with the help of MSS. MSS is by default 1460 byte, because MTU is by default what? 1500 byte. So it have subtract 40 bytes, 20 bytes for transport layer, 20 bytes for network layer. It is done with the help of MTU, and it is done with the help of maximum segment size, right? Segmentation is done for which type of traffic? For layer 3 traffic or layer 4 traffic, and fragmentation is done for layer 3 traffic only. Can now anyone tell me why fragmentation will not done for layer 4 traffic? Because fragmentation is not required for layer 4 traffic. Yeah, fragmentation is required for layer 4 traffic also, but for UDP based traffic only, not for TCP based traffic. Because TCP based traffic have already knowledge that minimum MTU is this one. So fragmentation is not required. Yes or no?
Yes.
Yes, Somnath, is it clear?
Yes, sir. I was just confused with those numbers, so I think I'm okay now.
Yeah, number is, nothing, size of data. You can practice it. You can capture the link between two routers and you can see by yourself. But things like, you have learned transport layer and TCP header, what will happen? Whenever TCP based traffic will be generated at client machine, transport layer will first build TCP connection with the help of three-way handshake. While three-way handshake, it will negotiate MTU, means minimum MTU. So transport layer will never generate the size of data that router cannot transfer. That is more than MTU, because transport layer or TCP have already measured the minimum MTU between source and destination. So fragmentation is required only for two types of traffic. First, network layer traffic, and second, UDP based traffic.
Okay, okay. From that MTU, it will subtract the header 20, right? Okay,
Yes.
okay. Understood.
And Prem, is it clear?
Yeah, it is clear. No. So one
So
doubt:
that, yeah,
can we set the maximum segment size manually, like how we used to do for MTU size? So like we're
yeah, like
do-
I was doing in ping command.
okay, okay.
We can set the size na ping
So that is
10.1.1.
basically MTU, right?
This is the size of data, not MTU.
Okay, okay,
Size
okay.
of data, size of one data should be what? MTU is this one. So IP interface F0/0 include MTU. MTU of fast Ethernet 0/0 is 1500 byte. This is MTU.
So based in on the interface, if you do the changes, so we can do that is MTU size, right?
Right.
And
And
to change this like maximum segment size, so like any other in the interface level we can do.
yeah,
No,
only
right?
interface level you can, I think, do. There is no command in global mode.
So that is MTU, right? And for maximum segment size.
For maximum segment size, like this.
Okay.
For maximum segment size will be decided by your client machine only. You cannot decide that. While three-way handshake, they will negotiate the minimum MTU. According to that, it will decide what will be the size of one segment.
Okay, got
What
it.
will be the MSS? Okay.
Yeah, fine now.
And guys, I am also teaching, revising these things after long time. So sometime maybe I am also confused with some topics. So please don't mind. Okay. I am but very clear with this concept. Don't worry, you will learn everything. And I know. Okay. But just I have not revised these things in last few days. That's why sometimes it's difficult to recall. But don't worry, when I will start the advanced things, or these are very basic things, or the important things, in those things I am very familiar now also, like in BGP, on OSPF, in EIGRP, in switching protocols, in packet flow, right? In these things I am still very familiar, but in these basic things like MTU, or we can say like segmentation, fragmentation, but still I am trying my best to make you guys understand. Okay.
It's clear, Prabal.
Okay, okay. So now here let's come on trans TCP header again. In TCP header, there is some more field which is not important for you, but let's see what it is. Like reserve field, it will be always zero. It is not used nowadays. Then we have some flag. Flag is for control function, which is used to set up and terminate the session. Like, as you know, TCP build one logical connection. First it will stabilize the connection, then it will terminate the connection. So with the help of flag field only, machine build or stabilized TCP connection. Okay. And it terminate TCP connection, like fin bit, sin bit. Sin message is nothing but sin bit on TCP header. What I am saying, sin message is nothing but sin bit on TCP header, and sin bit is a flag. SYN plus ACK message is also nothing but a TCP header where SYN bit and ACK bit is on. And acknowledgement message is also ACK bit on TCP header. So these three messages are TCP header actually, not a message of any layer or any protocol. SYN plus ACK and acknowledgement. These are TCP header. In
So it
SYN
is
message,
mentioned
you will
there
see.
are 8 flags in the TCP header. So I know about only 6 flags. So what are the other two?
Yeah, I think we have only 6 flags, right? In
Yeah,
TCP.
so
We have
I
only.
know like urgent flag, acknowledgement, push, reset, sync, and thing.
Yeah.
So these
Here is
six.
flag.
So I am not aware about other two.
There are 8 flag. And don't worry, we will discuss about flag also. But now you will get confused in flag. Flag is totally on control function. When we will understand packet flow, that time I will discuss flag.
Okay.
So there are 8 flag, not 6 flag. And then window size. This field already, you already know what is the use of window size in TCP. What is the use of window?
So declaring the size.
At after how much data client machine will expect acknowledgement? Yes or no? After what data transmission client machine will expect acknowledgement from receiver machine, that is window size. Means how much data sender machine will send to receiver without acknowledgement, we can say. Yes or no?
Yes.
And then we have checksum. Can anyone explain checksum, guys? What is checksum? Because in upcoming day also many time you will heard this word checksum at layer 2 also checksum. So what is checksum?
It is basically used for error checking. So there is some like algorithm running from the source side, and once the packet is received, so that time it will match the hash value. So if it is matching, so the data is correct. If it is not matching, the data in the middle it is corrupted.
Yeah,
Yes.
exactly. Like sender machine or receiver machine, both machine will use one algorithm. Let's say this is one algorithm. So what sender machine will do, before transmitting the data, it will put all the data in this algorithm and it will calculate one value, hash value. Okay, and it will transport in transport layer header. There is in TCP header there is one field called checksum field. In checksum field they will put that information, and when receiver machine will receive it, again receiver machine is going to use same algorithm. It will put all the data into that algorithm and it will also calculate one hash value and it will match. If both hash value will match, that means there is no any error in data. So this is for error correction. For error, not correction, error detection. Error detection. After that, urgent field is there. What is the use of urgent field? It is used to send traffic urgently. That means it is used for quality of service.
So in which case we use this urgent pointer?
In quality of service, let's say you want to mark some data, that this data is important, like ambulance. Let's say here I have one network switch and here I have one PC and here I have one, let's say, IP phone. Okay, IP phone and this PC both are connected with this switch. This switch is connected with one router. This router is connected with another router, and this router is connected with, let's say, again one PC, and here is one IP phone. Okay, so when this IP phone and IP phone will communicate with each other, this is voice over IP traffic, and voice traffic is delay sensitive traffic. So whenever router will receive, let's say, voice traffic and data traffic at the same time in the buffer memory, so it will process both at the same time. It will not give any priority to any traffic, but router should give some priority to voice traffic. If let's say both packet, one packet of data and one packet of voice is here in the buffer memory of this router, so this router should process voice over IP packet first. So this is like use of urgent point. So which traffic you want to send first? This is part of quality of service, guys. You have to learn the quality of service. Quality of service is also on course like CCNA.
Means this urgent flag will be set by the router only, right?
Right, by router only. Or
Depends on that which type of
while
service is sent.
sending data also at client machine also you can use this point. When you will add transport layer header, you can use this field, urgent point field. Just this is just an example, brother. Not only router can perform quality of service.
No, if we are sending that same type of data, means actually how it will take, actually which one is the preference?
It will, router will use first in first off,
Or otherwise actually we can make like a manual set.
yeah, by default router will perform this first in first out, and if you want to give some priority to some data, you can use urgent point.
How we can set this
Like
plan?
if router have received two packet, okay, in one packet urgent field is on and one packet urgent field is off, so the router will process which packet first? Urgent field on bits packet.
This
Okay,
urgent point is in TCP header, right? Usually
right.
router will not look into the TCP header, right? It will just forward it to the server.
Router can understand traffic of layer 1 to layer 7, but it forward traffic on the basis of layer 3.
Okay.
Okay, it can understand the traffic of all layers. And Prem, how many flag are there in TCP? 6 flag. Can you tell me the name of 6 flag?
Urgent flag, acknowledgement, push, reset, sync, and pin.
Fin. And reserve flag is also there.
That is
0x0.
okay. Okay. So that is having different value, right? That is
0
60
0.
6 bits actually, 6 bits.
6 bit is urgent acknowledgement, push, reset, sin, fin.
Yeah, and 6 is having for reserved.
Exactly.
Okay, then the other one,
Reserve.
so reserved, and then so
Reserve is
so I said for 6 and two more is pending, right? So you are saying that reserved is another one.
the one, and another one is fin, sin.
I think reserved is
Oh,
also there. So kindly check once and let us know, no issue.
yeah, definitely.
Okay, okay, thank
Urgent acknowledgement, push, reset, sin, and window. Window is there, I think.
No, 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 no. Window is not there.
Win window and reserve.
No, no, no. Window size is different actually. That is
Window
60.
flag. There is one, I think, flag like WIN.
I think no. You please check once.
Okay, I will check it.
Yeah, definitely.
Okay, so now can I move to network layer header, means IP header?
So actually, I just want to know. So in which case we use this reserved flag?
Reserve flag?
So reserved. So that is 6 bit, right? So in which case we use this one?
Reserve field is set to 0 always.
So in which case it will be one?
I think it is One, it is also, I don't know, I will check it.
Okay, okay.
Reserve field.
Reserved
In which
is for
scenario will use?
actually for future enhancements, right? It is not used currently.
Yeah,
So I,
maybe. Yeah,
yeah,
I also think.
yeah, I think so.
Maybe. We will see what is the use of reserve field, and I think nowadays we are not using it. Okay, so now next header is UDP header, and in UDP header you can see there are very less information like source port, destination port, header length and checksum. After that your actual data. Then IP header. In IP header, see first information is about version, and guys, length of IP header and TCP header both is same, 20 byte. So version, then again header length, then this field is used for toss, QoS, quality of service. After that there will be information about total length. So here in IP header we will have information of total length, means total size of data, and header length. That means we can identify what is the size of actual data at transport layer. Then we have identification field. Again, identification field is used for fragmentation. Whenever router will perform fragmentation, then identification field will come in picture. Then we have three bits for flag, then fragment offset, then TTL, time to live. This is also very interesting field. Then protocol is very important field here. After that header checksum, source IP, destination IP and option. This is IP header. Identification. If the IP packet is fragmented, then each fragmented packet will use same identification, same 16 bits identification number to identify that which IP packet they belongs to. Getting my point? So let's say router have received five fragment packet with same identification number. Then it will came to know that okay, these fives are part of one segment. And how receiver machine is going to rearrange it with the help of fragment offset list. Fragment offset. IP flag, there are three flag. You can see first bit will be always 0 here, and the second bit is called don't fragment the bit. Don't fragment the bit. So I can tell to router, let's say here on this PC, see when I am pinging 10.1.1.10, ping is working. When I am pinging with different size of 5000 byte, then also I am able to ping. And let's say I am going to say ping 10.1.1.10 size 5000, and after that df bit, don't fragment bit, df bit on. See, will ping work? No, it is not possible because I'm telling please no, not fragment, and size of data is 5000 byte. So how router can forward it, right? MTU is 1500 byte only, so it cannot transfer the data and it cannot fragment the data. So finally router have to drop the data. Okay, so if you will on this bit, router will not perform fragmentation. The last bit is called more fragmentation, more fragments bit, and set on all fragment packet except the last packet. What is the use of these bits? If this bit is on, if this bit is on, that means it is an last part of fragment packet. If this bit is off, that means it is not a last bit, last packet. Means more fragment packet is coming. More fragment bit is on, that means more fragment packet is coming. And TTL, finally, this is, we have already discussed this, fragment offset. Finally we have TTL, time to live. So guys, we will discuss time to live tomorrow. We will start this topic tomorrow, because time to live is a little bit lengthy topic. First I have to give you one example. Okay, so tomorrow I will start from here, time to live. After that, application layer protocols, and then I think, okay, IP address or packet flow. First we will cover IP address, IP addressing and subnetting, VLSM, and then we will move to packet flow. After packet flow, we will move to routing module. We will start routing, static routing, dynamic routing. Before it, again, we need at least, I think, 6 to 7 days, okay, to understand all the basic concept and packet flow. Yes, now if anyone have question, you can ask.